Unit 3 Chemistry, Chapter 6 Fuel Cells. So fuel cells are similar in many ways to the primary cells we were just looking at, and similar to the secondary cells that we're going to look at in area of study too. But a primary cell can only contain a small amount of a reactant. A fuel cell is different in that we keep on adding reactants and we keep on removing the products. So we can therefore get continuous production of electrical energy. They are so much more efficient than power stations. When we were looking at power stations, we will remember that we were losing the vast majority of the energy. We were getting about a 20 to 30% efficiency. Okay? In a fuel cell, you might be getting a 60 to 70% efficiency. So that's 60 to 70% of the chemical energy being converted into the useful form of energy, which is electrical energy. The reason is you've got much fewer energy transformations. We're going directly from chemical energy to electrical energy. They're so great, we use them to power space shuttles. One of the most common is the hydrogen fuel cell. There's actually a couple of different ones. Hydrogen's oxidized, oxygen is reduced. And we only produce water as a product, which is great because water isn't polluting. It is a greenhouse gas, yeah? But it's not a polluting greenhouse gas because it doesn't cause other problems as well. We have an inlet that allows addition of the gases and an outlet for the removal of water. Okay? There's actually a couple of different types. We can either do this in an alkali environment, or we can do it with oxide ions as your electrolyte. If we do it as an alkali environment, then the hydrogen gas reacts with those hydroxide ions to make water and a couple of electrons. At the cathode, the oxygen reacts with water and electrons to make the hydroxide ions. And then when we combine this, because we are using 4 electrons here, we double everything in this equation. Yeah. And then we're going to see that our hydroxide cancels out, our electrons cancel out, except I forgot to double those ones. You know it was supposed to be there, deliberate mistake, seeing if you're paying attention. And 2 of the waters cancel out, because you've got 2 waters here and 4 there, so we're going to cross out from the left and leave them just on the right of the arrow. So our overall equation, 2 hydrogens plus an oxygen, gives us 2 waters. If we had oxide ions in the electrolyte, we would have those hydrogen ions reacting with the oxide ions to make water. And at our cathode, the oxygen is just combining with some electrons to make oxide ions. Okay? The overall equation, we'll combine it, we'll cancel down, the oxide ions cancel out, the electrons cancel out, and you end up with the same overall equation. And of course you do, because it's still hydrogen plus oxygen giving you water. But it's important, whenever you're doing this sort of question, to look at what the electrolyte is. Because the electrolyte is going to tell you what you can make and what you can't make. Yeah? Because whatever ions are in your electrolyte, they're going to be made at one and used at the other. So here we've got hydroxide ions, here we've got oxide ions. And it's very important that you check anytime you are looking at a fuel cell. Might be in the written information, might be on the diagram. Look for it. Okay? So this could be either, because it just says electrolyte. Yeah? The question may tell you which one. This is the sort of thing we're looking at. Oxygen gas going in, hydrogen gas going in on the other side, water coming out. These, they say, are porous, which means they've got little holes in them. You can see that, we've got little dots on them. And that allows the gases to flow through. In a fuel cell, they're also generally embedded with a catalyst, which allows them to occur. And just like all electrodes, their primary function, of course, is for the conduction of electrons. What do we use fuel cells for? A whole range of different things, and there's lots of different ones out there. We can use them for, well, the alkali one we were talking about before is used in space vehicles. The other ones we could use for production of electricity. That's what we mean by electricity utility. We could use them for portable power transportation. Problems. Why we don't use them, why you don't see them around the place. It's really problematic to keep on adding reactants because you could add something that you didn't want to, which would completely mess up your system. Could destroy your catalyst, yeah? The electrolytes often have to go for and the catalysts can often be really, really expensive. And the technology is also really expensive. Okay. The other thing is that in many cases, what we are doing is transporting and moving around some fuels which are exceedingly dangerous. Hydrogen gas, for instance, is a very explosive gas. So if I just tried to transport hydrogen gas around in my car, it's possible that my car might explode, and I'd rather that didn't happen. Okay. Comparing them to galvanic cells, they are much more expensive. Okay. Both of these, we're converting chemical energy to electrical energy. Okay. A fuel cell has to be a fuel reacting with oxygen. A galvanic cell can be any oxidant-reductant pairing. Okay. They both have the reactants separated. Okay. In a galvanic cell, they're linked by a salt bridge and an external circuit. In a fuel cell, we're in one container, and we have a porous separator that allows the ions through, but keeps the reactants away from each other. Okay. Fuel cells have got much more scaled up potential uses. So electricity production, powering vehicles, whereas these tend to be used on a much smaller scale for things like powering your laptop and your mobile phone or other devices that you might have around your home.